Good evening, class. We are looking at college algebra practice test number 4, module 4, covering chapter 7 and 8. Here's chapter 8, analytic geometry. And as always, we have the pledge asking everybody to make sure you do the job on your own without any help. All right, find an equation of a circle with its center at 1, -2 and radius 2. Graph the circle. So let's discuss the concept of a circle to begin with. And so what is a circle? A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. What about the equation? If it's centered at 0, 0, with the radius r, following Pythagorean theorem, x squared plus y squared equals r squared. If it's centered at h, k, any point on the circle with coordinates x, y. So x minus h, quantity squared, y minus k, this distance quantity squared, equals the hypotenuse, r squared. So those are the equations. So reminding you also of the fact that the area is pi r squared, circumference 2 pi r. So in this case, r is given, the center is given. So we're going to put it into this equation. We get x minus 1 quantity squared plus y minus -2. That means y plus 2 quantity squared equals r2 squared, giving us 4. So obviously we start with the center 1 to the right, -2, 2 down. So that's the center. Now, from the center, we are going to go r units, in this case 2 units, to the left, to the right, and then above and below the center, because we want to make sure we have a decent graph. So r specifically for this is 2 units to the left and right. So this one, if I want to go to the right, 1 plus 2 is 3, -2. If I want to go to the left, 1 minus 2, -1, -2. So those are the two pairs. Now we want to go from the center up and down r units. So if I want to go up, the x coordinate remains the same, the y coordinate. I go up by 2 units, becomes 0, so 1, 0. I go down by 2 units, becomes 1, -4. So r equals 2 units up and down. Those are the two pairs. Now put them together, and that's your graph. Okay. Now, I use those 4 pairs to help me graph. I want you to know that. Now, write the equation of a circle in standard form, identify the center and the radius, graph the circle. So this is not in standard form. Standard form is this or this. And so what we do, we put x squared and -4x together, y squared and 10y together, and the constant moves to the right, becomes +7. The reason we do that, because we are going to do completing this square. So in this case, b is -4. To complete the square, we divide the b by 2. We get -2. And then we square it. We get +4. In this case, b is 10 divided by 2, 5. Square it, 25. That means over here, I need to add 4. So I add 4 here and here. Over here, I need to add 25. I add 25 to both sides. So the left side is x and b over 2. That means x minus 2 quantity squared, y and b over 2, y and 5 squared, y plus 5. And we add 7, 4, and 25. We get 36. And so now, obviously, the radius is 6, and the center is located at 2, comma, negative 5. So here's 0, 0, everybody. We go 2 to the right, 5 down. That's the center. Now, from the center, I'm going to go to the left and right by r units. So if I want to go to the left and right, so the x coordinate to the left, 2 minus 6 is minus 4. To the right, 2 and 6 is 8. So we get minus 4 minus 5, 8 minus 5, okay? And now up and down. So for the y coordinate, you subtract, you get minus 11, you add, you get 1. And those are the pairs. You put them together. It is straightforward, everybody. Graph the ellipse by finding its center and vertices, x squared over 25 plus y squared over 16 equals 1. Well, here's an ellipse. Any point on an ellipse has coordinates x comma y. And here's the definition. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. So that means if you pick a point on an ellipse, okay, these are the two fixed points, the sum is constant. The two fixed points are called the foci. Each is a focus of the ellipse. So we have two of them. Okay, so in this case, that means PF1 and PF2, the distance is fixed. F1 and F2 represent the two foci of an ellipse. So PF1 and PF2 is equal to 2 times A. First of all, class, here's the center. This is 0, the center that's 0, 0. This distance is A. This is the x-intercept at A0. This is the other x-intercept at minus A0. This is the y-intercept at 0b, and the other one at 0, negative b. Now, if you pick any point, and connect it to F1 and F2, it is fixed. What is that fixed? It's this distance, A times 2. Why is that? Because if you look at this point, A, F1, any point will do the job, right? If you pick this point, this distance is AF1 plus AF2, and AF2, this distance, this is AF2, is the same as this distance. So we can replace this distance with this, and it becomes from here to here, which is through A. That's a proof, believe it or not. Also, if we pick a point here, let me erase my work. If we pick this point and connect them, this distance from here to here and from to here must also be to A. So that means these two must be each one equal to A because by symmetry they are identical. So if this distance is A and this distance is C, so I want you to look at this right triangle. This distance from the center to focus is C. By definition, the distance from the center to the y-intercept is B. So that means B squared and C squared, they add up to A squared. So we write the following. First and foremost, this is the equation of an ellipse centered at 0, 0. X squared over A squared plus Y squared over B squared equals 1. If it has a different center, X minus H quantity squared over A squared plus Y minus K quantity squared over B squared equals 1. The area is pi AB. I'm going to discuss that in a moment. B squared and C squared, they add up to A squared. So this distance is A. Remember that. This is from the distance here, you can see it's C. This is B, and this distance ends up being A. Note, a circle is a special case of an ellipse where A and B equals R. If this distance, which is B, and this distance, which is A, they are identical, this changes to a circle. In other words, F1 and F2 come together and become the center. Now, the area of a circle is pi r squared. So with this in mind, the area must be pi times A times B. Remember, when A is equal to B, we get R. So that's how we arrive at that. All right, we are ready to actually move on. So I just wanted to give you a synopsis of what is an ellipse. So I'm going to erase my work. And so in this case, comparing it to that, it is centered at 0, 0. A is 5, B is 4, square root of 25, square root of 16, according to this. So you compare to this one, and you see that. Now, when A is larger than B, this ellipse looks like that. It's elongated along the x-axis, and then A0 and minus A0 are called vertices. In this case, the center is at 0, 0, and this one is at 5, 0, and negative 5, 0. So this is the center. Vertices at 5, 0, minus 5, 0. So because A is larger than B. Now, the other ones, the other two y-intercept are called the co-vertices, 0, 4, and 0, negative 4. Now put them together. That's the shape. And by the way, the closer these two values are, the closer the shape looks like a circle, okay? Now, if B is larger, it's elongated this way, then the vertices would be on the y-intercept, and this will change also. Please understand, this Pythagorean theorem relationship on this side is the one that is the largest. In this case, in this shape, A, which is this distance, is larger than B, and C is somewhere here. We can calculate it, just following B squared plus C squared equals A squared. We'll do that in a moment, or a different one. Actually, for this one, we can quickly do that. 25 minus 16 is 20. It's okay. So A squared minus B squared is C squared. So 25 minus 16 is 9. And C is plus minus 3. It's the location. So this would be 1, And this would be another. Okay, so,
Thank you once again.
and in all cases,
I will be sharing the goal.
and in all cases, okay, the C, which is this distance, the B, which is this distance, smaller than A. Therefore, B squared plus C squared equals A squared. But if B is the largest one, then C squared plus A squared becomes B squared. Identify the coordinates of the center, the vertices, the co-vertices, and the foci. Graph the ellipse. So when we look at this one, we're going to compare it to this one. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. And therefore, clearly, the center is located at minus 5, positive 7. A squared is 4, so A is 2. B squared is 9, so B is 3. And that means it's elongated along the y-axis. That's the meaning of it. So we start with the center, and this is 0, 0. So we go 5 to the left, 7 up. We have the center. Now we want the vertices. So back to the center. Because B is larger, we're going to go up by B units and down by B units. So in other words, add 3, you get 10. Subtract, you get 4. Minus 5, 4. Minus 5, 10. Those are the two pairs. Back to the center. We are going to go A units to the right and left. So minus 5, 2 units to the left takes us to negative 7, 7, and to the right, minus 5 plus 2 is minus 3, 7. So we get those two pairs, connect them, and that is an ellipse which is elongated along the y-axis. In other words, B is larger than A. And now, remember, B squared plus C squared equals A squared, but either A squared plus C squared is B squared or B squared plus C squared is A squared. It depends on which one is larger. Obviously, since B is larger, then A squared plus C squared is equal to B squared. So A squared is 4, C squared is missing, B squared is 9, 4, this is 9, C squared is 5. And C is actually is a distance, so it's positive square root of 5. But the idea is that from the center, you go up by C units and you go down by C units. That would be the location of each focus. So that being the case, the X coordinate doesn't change. The Y coordinate 7 plus square root of 5 and 7 minus square root of 5. Okay. And those are the pairs, everybody. It is straightforward. Use the graph of the ellipse to determine its equation in standard form. And of course, we want to go with that. So the first thing we look at is the center. Clearly, it's located at negative 2, 2. Now, let's look at these 2 points and these 2 points. These are the vertices. Those are the co-vertices. So those are the 4 points that are important. So this one located at negative 2, 5. This one, negative 2, negative 1. This one, negative 4, 2. This one, 0, 2. So we can locate those. This distance is B, this distance is A, so we have these two distances. This is obviously the distance of what? 2A equals 2. This is the distance of 3, B equals 3. So now we are ready to write x minus 2. That means x plus 2. Quantity squared over A squared makes it 4. Y minus 2 quantity squared over B squared makes it 9 equals 1. So that's the equation. Very straightforward. And again, if you want to find the location of the foci, you can do the same. In any way. So that's as far as ellipses are concerned. Now give the equation of the asymptotes and graph the hyperbolas. One of them is x squared over 16 minus y squared over 25 equals 1. One of them is y squared over 25 minus x squared over 16 equals 1. And notice the difference between this and an ellipse is that we have a negative sign here. So what happens when we have that? Let's discuss the issue in general. So here's the graph of a hyperbola, okay, that opens sideways. The vertex in this case is located at, those are two x-intercepts at a0 minus a0. 0b and 0 minus b will help us with the graph, but of course it's not part of the graph. And these two lines are dashed lines because those are the asymptotes. The equation for the asymptotes is plus minus b over a times x, okay? And this one is a fundamental rectangle that if you graph them properly, the diagonals become the two lines that we are interested in. So, what's a hyperbola? A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. Pf1 minus Pf2 equals 2a, since af1 minus af2 equals 2a. In other words, if you pick a point, any point, on this piece, doesn't matter. Connected to the two, and obviously Pf1 is larger than Pf2. So Pf1 minus Pf2 is fixed, happen to be 2 times a. And again, this distance, everybody, is a. Okay. Why is this 2 times a? Because if this point is anywhere and it works, let's put it here. So a f1 minus a f2. I hope you realize that there's a different color that will be helpful this one. This distance and this distance are identical by symmetry. Therefore, AF1 minus AF2 equals 2A. That's the proof. Now, whether we have it in the format of x squared over a squared minus y over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1, if we keep the a squared under x squared in both cases, and b squared under y squared, both cases y equals plus minus b over a times x would be the asymptotes. That's not how every text goes by. I go by this one, so therefore the equation for the asymptotes remain unchanged. And a squared plus b squared equals c squared. This doesn't change because a and b are always smaller than c. So let me show you. This is the distance a. This is the distance p, everybody. And from here to here, or from here to here, this distance or this distance is c. So therefore, c is always larger than a and b. And so a squared plus b squared remains at c squared. It doesn't matter that opens sideways or opens up and down. Okay. All right. So when we look at both of them, first and foremost, we notice that the center in both cases is at 0, 0. A is 4, B is 5. So in both cases, this doesn't change. So here's the center for both cases. The asymptotes plus minus b over a times x is the same for both of them. So you just graph them. Now, it's important to know to graph that, you can pick up a couple of pairs. I do it two ways. One is that just think about, let me just do one of them, 5 over 4x, for example. You can just pick a couple of pairs. Obviously, 0, 0, right, is one of them. Now, because this is 4, that means if x is 4, y is 5. You follow what I'm saying? So that's one way to look at it. The other one, I will look at this fundamental rectangle. When we are done, I'll show you how to find those asymptotes using the fundamental rectangle. Might be a tad faster in a moment, but let me erase my work now. So the vertices for this one are at 4, 0 and minus 4, 0 because remember, x squared has a positive coefficient here. More specifically 1 over 16, this one y squared. So for this is the fundamental rectangle that I mentioned. It's the fundamental rectangle that I mentioned. Let's just write those numbers. These are, let me see what color will do the job, and then I have to erase it. So let me go with this color. Okay. This point, okay, 4 comma 5. See, we are looking at this one, right? So if you have a equals 4, b equals 5, so this is 4 comma negative 5. This one is negative 4 comma 5. This one is negative 4 comma negative 5. So those are the four corners. If you draw this rig, and again, it's dashed line, it's not part of the graph. You can draw, and it's the same thing for this guy too. These endpoints are the same as what I wrote up there. So that might help you find the two asymptotes fairly fast. So the vertices for this one are at 4, 0, minus 4, 0. And it opens this way, open side. Now, for this one, everything is identical to this so far. What is the difference? Y squared has a positive coefficient. So now the vertices are along the y-axis at 5, 0, 5, 0, negative 5. So at 5, 0, 5, 0, negative 5. These are the two pairs. And this is the graph. So what's important? Let me just erase something. Okay, erase everything. And let me just do this. Have those pairs, the endpoints of the diagonal that helps find. that. So for this one, x squared over 16 opens sideways. For this one, opens up and down. That's the difference. So the difference would be the vertices. I hope everybody is comfortable with that. We are going to move on. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptote. Graph the hyperbola. So x minus 1 quantity squared over 9 minus y minus 2 quantity squared over 16 equals 1. And of course, we are going to compare it to this one. And it's a hyperbola because it's a negative sign here. Obviously, the center is located at 1, comma 2. A equals square root of 9 over 3. B equals square root of 16 over 4. So those are given. So the center is located at 1, 2. So 1 to the right, 2 up. Now, what happens to the asymptotes? Remember, if asymptotes are y equals plus minus b over a times x. That's for the basic one where the center is at 0, 0. Now, if the center is at k and h, then next to y you write minus k, and next to x you write x. In other words, you just write exactly what you have here. So y minus k plus minus b over ax minus h, that means write this one, whatever you have here, y minus 2 here, and write this one here, plus minus b over a 4/3, and write this one, x minus. That's all it means. Now, we are going to move the negative 2, make it positive 2. Then we have two asymptotes, positive 4/3 and negative 4/3 in the following manner. Let's work it out here. Y equals 4/3 x minus 1 plus 2, which is 4/3 x minus 4/3 plus 2. Okay, and these two add up to 2/3. So that's one of them, everybody. And if you want to graph this, this is the y-intercept 0, 2/3. 0, 2/3. And if you set this equal to 0, so this is one of them, 0, 2/3. If you set this equal to 0, okay, I hope you see that x becomes negative 1/2. You can easily solve it. So we have those two pairs, and we can graph the first one. We're going to go over the second one in a moment. But before I do that, it's important to know that as far as graphing that, you have the y-intercept and it has to go through the center. It will go through the center. You can stick with that. Now, for the second part, and let me erase my work. For the second part, this one, y equals minus 4/3 x minus 1 plus 2, or minus 4/3 x plus 4/3 plus 2. These two add up to 10/3. And again, 0, 10/3, and then this one, put them together. Or if replace the y with 0, I hope you can see x becomes 5/2. I'm going to leave it for you to verify that, but 0, 10/3 is clear, and that is the second asymptote. Let me erase my work. Now, so we have that. And A is 3, B is 4. We are going to, and by the way, the coefficient for X, or in this case, X minus 1 quantity squared is positive. So that means it opens sideways. So we are going to go A units to the right and left of the center. A units, A is 3. So we go 3 units. And this is 4, 2. To the right, we go 3 units to the left. 1 minus 3 is -2. So we get those two pairs, -2, 2, 4, 2, or those two pairs, and just connect them. And remember, the concept of asymptote, this will run along the asymptote. It never goes through that. And that's the graph. Now we want to find, so we have everything, and now we want to find the foci. And the foci, remember, are somewhere here, right? So we have the y coordinate, we want to find the x coordinates, and we are going to go with a squared plus b squared equals c squared to find c. A squared plus b squared equals c squared. A is 3, that means 3 squared, or you already have 9 and 60. Okay, so they add up to 25. So you can, so you have them. So this is 25, everybody. So c is equal to 5. And the center, this c is the distance from the center. The center is located at 1, 2, and lowercase c, the focus has a distance of 5 units. So having said that, we're going to go 5 units to the right and left of the center. So here's the center. If I go 5 units to the right, 1 plus 5, 6, 2. If I go 5 units to the left, 1 minus 5, -4, comma 2. So those are the foci. And by the way, this is the fundamental rectangle. Okay, everybody, okay, look at those. So this is as involved as it gets, and that's it. Use the graph of the hyperbola to determine its equation in standard form. Clearly, the center is here, and so we're going to go with that. So the center is located at -1, 0. We need to find A and B. So we look at the vertices. This is one of them, this is one of them. So the vertices are located at -1, comma 3, -1, comma -3. The graph indicates that. So this much, that means it's located this much above the center and this much below the center. That is the B units. So located B units up and down from the center. So they have the same x coordinates. The difference between 3 and 0 is 3, or this 2 is 0 minus -3. So B must be 3. This distance must be 3. Foci are located at -1, 3 squared of 2, and -1 minus 3 squared of 2. There are 2 of them. This one. And so this distance from the center to one of those focus, that is C. And this distance is given, because this is located at 0, this distance is given as 3 squared of 2. And no matter what, A squared plus b squared is c squared. Always. A squared plus b squared is c squared because c is always larger than both a and b in the case of a hyperbola. So we write it. A squared plus 9, 3 squared squared, and this is 9, this is 3 squared 9, this one is 2 times 9, 18, and so a squared is 9, a becomes 3, and so because it opens up and down, y minus k squared over b squared minus x minus h quantity squared over a squared equals 1. This is the formula we use. Doesn't open sideways, opens up and down. And b squared and a squared happen to be equal, they are 9, okay. And basically we're done, but just to write the asymptotes, remember, y is plus minus b over a times x, or in this case, y minus k, so this remains as y minus 0 over y, plus minus b over a times x plus 1. And of course, b and a happen to be the same, everybody. B and a are the same, they cancel each other. This is just y, so plus minus x plus 1. These are two equations. I want to make sure everybody understands that these are, one of them is x plus 1, one of them is minus x minus 1, okay? Therefore, you can graph those easily. I'm going to assume everybody knows how to graph them. This one has the y-intercept 0, 1 and use the center. This one has the y-intercept 0, negative 1 and use the center, okay? This is 0, 1, 0, negative 1. And of course, you can see the fundamental rectangle as well.